guys ready? All right, we're going to do lesson 1. We are not going to do the warm-up. Big idea from yesterday is this. There's 2 different ways to talk about inverse functions. The old school way is using the word arc in front. Arcsine, arccosine, arctangent. The kind of new age way of doing it is to use the little inverse symbol, which is here. Okay, it represents the inverse function. That's why we use it. So we're going to go back over these examples. I believe we did these 3 yesterday as an introduction. If you take a look at number 1, when they ask you to evaluate the arc sine of -1/2, they are saying within the restrictions of inverse sine, where do I have a sine value in radians of -1/2? So let's quickly review over here on the right. What were the 2 out of sine, cosine, and tangent that were the same? Sine and tangent. Okay. So sine and tangent both run from pi over 2 to -pi/2. So your choices basically are those areas. Now the one thing to remember is in quadrant 4, these are not the unit circle values that I asked you to memorize. These are going to be the coterminal negative angles. So if this is -pi/2, this one is going to be -pi/3, -pi/4, -pi/6, back to 0. Yes? Then the other arc, if you will, which is kind of interesting, is going to be cosine, which I think we all know is quadrants 1 and 2. They're the same values that you had to memorize. None of the answers for these should come from quadrant 3. So if we look at example 1, where in this purple region do I have a sine that is -1/2? In other words, a little bit of y. -pi/6. That's the answer they're looking for. In example 2, they're also asking you for the inverse sine function. They're just using different notation. And they're saying where on the unit circle within the restrictions of the inverses do I have a y value that is positive root 2 over 2. So again, we're in the purple arc. What's our answer? Pi/4. Arc cosine. We're now going to switch to the blue arc because the inverse cosine function is only defined between 0 and pi. And we're saying where do we have a cosine value that's a whole lot of negative root 3 over 2 in the x direction? Whole lot of x in the negative. What did you say? 5pi/6. So these are the simplest ones where they're just going to give us one inverse at a time. The next slide is what we call nested functions. So just like order of operations, we're going to start on the inside, we're going to substitute, and then we're going to work to the outside. So these are called compositions. All right. So the first thing we're going to do is we're going to start inside of this bracket and say, all right, where on the inverse function of sine do I have a y value that is -1/2? -pi/6. So this gets substituted in as the solution for in the brackets. Now you're going to use your full unit circle and tell me what is the cosine at -pi/6. So we're right here. What is the cosine? The answer is on your paper. Positive root 3 over 2. This is the final answer. You get it?
Yeah.
Yeah, but I want to finish, let me finish this first. Okay, example 4. This is another nested or composition function. We're going to start in the brackets. Now we have to think about tangent, right? Where is arc tangent +1? Well, tangent inverse is only defined in 1 and 4, so what quadrant do I know I'm in? Quadrant 1, And tangent is 1, which means that y over x has to be the same thing. Y and x have to be the same thing. So which value in quadrant 1 has y and x as the same thing? Pi over 4. So I'm going to substitute pi over 4 for what's in the brackets. Can you tell me what the sign at pi over 4 is? Root 2 over 2 is the answer that I'm looking for. So we're going back and forth between you telling me what the x's are, you telling me what the y's are, you telling me the radians, etc. Now, let's put a star by example 5. Star there, please. In example 5, when I look at my brackets, I should feel a little panicked because is 5 over 7 a unit circle value? No. Okay? So this is an example that is going to go back to our reference triangles. They are not unit circle values we can think out. Therefore, we're going to draw a diagram. Some of you will like the diagrams a lot better for this. So, let's talk about just what's in the bracket. If cosine is negative, based on the inverse cosine quadrants, am I going to draw the reference triangle in quadrant 1 or 2? Quadrant 2. So, I can set up my coordinate plane, and I can draw my reference triangle. Remember, the reference triangle is always a right triangle drawn using one of the legs as the x-axis. Okay, now the idea here is that this is the O, this is the A, this is the H. A is negative, the opposite is positive based on its placement in the coordinate plane. What do you know about all hypotenuses?
For 1.
It's always going to be positive or negative? Positive. It may not be 1 if it's not a unit circle value. So if I look here, cosine in a triangle is ratio of what two letters? Cosine in a triangle. This is the adjacent and this is the hypotenuse. So my adjacent side is -5, my hypotenuse is 7. Can you use Pythagorean theorem and a little bit of mental math to tell me what the opposite side is? 49 minus 25. 24, right? This is the square root of 24. What does the square root of 24 reduce to? Right? 49 minus 25. 24. The square root of 24 reduces to 2 root 6. And now, you have your reference triangle, bless you. Now we want to calculate the tangent of this angle. So what is the tangent of opposite over adjacent? So it's going to be 2 root 6 over -5 is my final answer. Get it? Got it? Good. Your assignment is the worksheet on the back. Enjoy.